So we've talked about the nucleophile in our SN2 reactions, what types of things about that nucleophile actually made the transition state lower in energy and therefore the activation energy lower, reaction faster, what types of things did that, and those nucleophiles that were able to lower the transition state energy, lower that activation energy, made the faster reaction. Those were better nucleophiles when we're comparing it to something else. So what we're going to talk about now is the electrophile itself, because both the nucleophile and electrophile are involved in that rate determining step. So they're both important to talk about how they each affect that rate of the reaction. So for electrophiles, now we're going to be talking about what makes better electrophiles in this SN2 reaction. And what we're going to be focusing in on is the alpha carbon itself. What we're going to be kind of now focusing on that right-hand side of the transition state as the way that we've been drawing it. So our nucleophiles are going to stay pretty consistent. For our examples, we're going to be looking at the electrophile. So we're going to be looking at what's happening around that alpha carbon. What other groups do we have attached here? This was just our original example that we saw very early on for that SN2 reaction. And so we're keeping that consistent example here. If that first one that we saw, we can have other groups around that alpha carbon. What does that mean for the reaction rate? How is that going to affect things? And we're also going to talk about the leaving group itself. That's the group that's pulling on that alpha carbon. It's going to have to be able to stabilize that electron density once it leaves. While it's in the transition state, it's already starting with that stabilization of the electron density as it's starting to break, as that bond's starting to break and it's starting to get that electron density. That delta minus is going to be key in terms of how well is this atom stabilizing that partial negative, because that's going to tell us how well is it actually stabilizing that negative charge too. So in that transition state, that is going to matter the most, because that's going to influence that activation energy, how well this leaving group is stabilizing that delta minus that's starting to develop. So we're going to look at the alpha carbon and what does it look like around that alpha carbon? How is that going to affect the reaction? And then also on that electrophile, because the electrophile has the alpha carbon and the leaving group attached. We're going to then talk about the leaving group and how does that help or hurt that reaction.